Those of you watching the videos, here's a warm-up problem. I'll show the answers in a sec, but you might want to pause it. Okay. Alright. Okay, here are the answers. Alright. So, that's what we looked at on Thursday. What I want to look at today is kind of the second part of this descriptive statistics, and that is, rather than looking at measures of central tendency, or where is our data centered, okay, we're going to look at measures of dispersion, okay, measures of dispersion. In other words, how is data distributed or spread out, okay? There's one term here, the variance. Okay. The variance of our data is the mean of the squared differences of the scores from the mean of the set. Okay? The mean of the squared differences of the scores from the mean of the set. Now that's kind of a wordy explanation, but I think that'll make sense once we see the formula here. If I took all of my data and found out how far away from the mean it was, so, going back here, if I took these 8 zeros and said, okay, they are each, minus 1.49 away from the mean. All of these 1s are minus 0.49s. All of these 2s are a plus 0.51. All of the 3s are a plus 1.51, and the 4s are a plus 2.51. If you added all those up, what would you get?
Shouldn't you get 0?
You should get 0, okay? Because a mean is a measure of the center. It's a center in the sense that all the distances of the scores from the mean added up, the ones on the bottom will add up to the same as the number on the top. So if you're looking at them as negatives and positives, then you get 0, okay? The variance kind of takes that idea. We find the distance from the mean, but then we square those distances, okay? And we find the mean of all of those squares, okay? The standard deviation is used a little more than the variance, but the standard deviation is the mean distance each score is from the mean of the set. Alright? It's the average distance each score is from the mean of the set. Now these are related because in variance has basically 2 items of notation. You can either use an S squared, actually 3, okay? You might see it referred to as V. You might see it referred to as S squared, okay? Or, we'll put equals. Or you might see it referred to as a lowercase sigma squared. Okay, that's what that is. It looks like a little 0 with a baseball cap on, okay? It's a lowercase sigma, alright, but sigma squared. Now, the S is the variance of a sample. The sigma squared is the variance of the population, okay? We're not going to get into it enough to really make a distinction in our class, but because we're not going to talk about sampling per se. Your book just uses V, okay, and using your book's definition, V is that population variance, okay? So we're not taking into account any kind of sampling or anything. But then also we have the standard deviation is sigma, okay? Sigma, and that is the square root of V, which makes sense if you consider that sigma squared is V. It's the square root of the variance. So notice what we're doing here. We're taking each score. We take each score. Here's x1, x2, x3, x4, all the way to x sub n. Okay? Each one of those we are subtracting x bar. Notice there's a x bar, the mean. Okay? And then we're squaring that. We square it to make sure they all end up being positives. Okay? Then we add them together and divide by n. Alright? Another notation for this, and this is one that's a little more common because it uses sum notation. But your variance is the sum from I equals 1 to n of x sub I minus x bar squared all over n. Okay? So that's your sigma squared or your variance. Okay? And I would like you to be familiar with both items of notation, the sigma squared and the variance. Now, the easiest way to do this is to stay organized, okay? We're trying to find, if we're trying to find the standard deviation of some data, the best way is to set up a table, okay? Now, also on Thursday, we had found the mean, or we were given the mean of these different salaries, okay? And the easiest way, if you remember, we had the interviewer who was going in, and the guy who was interviewing him said, all right, the average salary at this company was $60,849. You guys remember that?
Yeah.
Okay. From Thursday. Okay. Here we were looking at the mean, median, and mode, and we saw that the mode was 12,500. We saw that the median was it 33? Hang on.
I think it's 32.
30. I know it ended. It was either the 451 or the 541. Hang on. $451. There we go. Median. And we were saying that in that situation, the median was a better representation of the data. Okay? Now, we're using this same data though, but we're looking at the mean. Okay? We're going to look at how to find the standard deviation. Now this can be kind of a tedious process, but it's one that you have to just be careful with and do everything neatly, otherwise you're going to lose track. Okay? So the first thing we're going to do is we're going to take each score and subtract the mean from it. Alright, so 60,849 subtracted from 12,500. That's going to be a negative. Okay. Negative 48 349. Okay. 48,349. This is also going to be a negative 48,349. Okay.
44419.
Okay. What about 17,305?
It's 43544.
Okay. And 17,408?
43.
Some of you could work ahead on some other ones to help us out here.
43441.
43441. Okay.
Minus 41869.
Great. And 20,432.
4417. 40417.
Okay. 24,540.
36309.
Okay. 25,676.
Oh, wait, 35173.
Okay.
31943.
Okay. And then
31893. 31893.
yep.
28195.
Okay. 33,450.
Can you keep up?
Okay, 27399.
Okay. 33855.
2699 4.
Okay.
That's 25866. This is
Okay. Next one.
Isn't there like a sum you can
okay, 25178.
Okay.
24309.
All right.
23996.
Okay. Next.
2399.
23499.
I just got 23399. That's what it was.
399. Went the wrong way.
minus 15171?
No.
Hey, so did you screw up?
Minus 11.
It's 1517.
86.
I just said that.
9.
Okay.
It's 151.
Okay. Which one? What was this, Marina?
11869.
CJ, if you could call me then I'll punch you.
Next one is last
33175.
475.
Okay.
37361.
417471.
41.
417471.
That's the last one? Okay. Hang on. We missed the next to the last one here. The 250,921. What's that one? Should be 190.
Yeah, 072.
Okay. All right. Wait.
Knowing you.
4147. Wait, what was this last one again?
414
714. There we go.
714.
Okay.
471.
By the way, so you can actually see here
The last one?
why the mean is not a really good representation of the data. Look how many of these are below the mean, and then you only have 4 of them that are above the mean.
The last one was 417471.
417.
471. Where's
417
4, 7,
471. Okay. Alright. So now we have all these numbers, and what do we have to do with all these numbers?
Square them.
We have to square them, okay?
Yeah.
Like I said, this is a tedious process.
Best
Alright.
done in Excel.
Best done in Excel,
They have
yes.
a little function for it.
Okay. Now,
You can't do this on your calculator.
Excel.
You just hit standard equals standard deviation, highlight a column.
STDEV, parentheses, A1 colon, A whatever, and
Yes.
yeah.
You could just highlight.
Nobody,
Okay.
nobody does it like that.
So here's the deal, okay? You have all these numbers, then you have to square them all.
and
Okay.
divide them by-
Alright, now let me show you, since we did one of these by hand, grab your calculators real quick. Too many things open.
You always have
And
everything
in case.
There we go. Actually, let's see, too many things open. See, like, Mr. Otis's Internet Explorer or Google Chrome, he'll have like 50 tabs open or something. It's
Oh.
funny.
else.
Then they'll try to find stuff in a meeting. But,
I actually can find stuff even though I have like a few windows open with like
yeah.
unlimited number of
Just have two monitors.
come on. Start up.
Overflow.
There we go. Okay, so what's a better way? All right. One way
Make a matrix.
is to use, well, not matrices, but lists. Okay? So you have these curly braces that are above your parentheses. So hit second parentheses.
I got it.
It's this curly bracket right up here. You can't really see because it's in blue. All right, but it's above the parenthesis. Then you have to type in all of your data. Okay? Now, that's the only tedious part to it. But I will say, be careful when you're doing it that you type it in properly. Otherwise, obviously, all your numbers are going to be wrong. Okay? So, you have 12,500, comma, 12,500. Okay? Guys, get your calculators out and do this with us, okay? So that you have some practice doing it.
This is the same thing
This
for
side?
Terry.
Yes, Kenny.
You can do the same thing on the Inspire as well.
16,430, comma,
16, 4,
17.
Alright, don't say the numbers out loud because everyone's in a different spot and it'll get confusing, okay?
Kenny,
Can we do the first numbers or the
Kenny, go
second
back to
numbers?
sleep.
Go ahead and do the first numbers because I'll show you how to do the second numbers a lot faster than what we did. Okay? Okay, so
Why did we do that?
What if there's an app that you can just take a picture of the list and it calculates it for you?
There is. I don't know about an app with our programs.
Yo, there's your $1 million right there.
Okay, so that's already like a thing. I don't know if there's an Apple app for it, but you can do that.
We should make it.
Kenny, you want to design an app with me?
Not with you.
Racist place.
Deal with CJ.
CJ's just CJ. CJ. I know.
He's hurting my eyes. I copy this wrong, I swear. 3, 4, 9. Oh,
Actually,
What do you do when you're done? Can you scroll down to like the last one?
Yeah.
It's 47832.
What was it, Kenny?
What was the last one?
478320.
478320.
Do I
Okay.
close the bracket thing now?
Yeah, close the curly braces once you have that. Okay.
So much
What was the last number?
478320. At least according to those guys.
So Kenny,
478320. Yep.
Kenny might have misled you.
Okay. Now. How's it coming? We got them all?
Almost.
Alright. Once you do that, hit the store button. Okay, because the last thing we want is to lose all this. Okay?
I'll throw my calculator at the wall if that happens.
Hit stow right here. And then L1 is above the 1 key. So hit second L1 and hit enter. Okay?
What is L1?
Yeah.
For you,
Or is it just?
you guys can just, it recognizes if you just put A, B, or C, or just put,
So like this?
just pick a variable. Yeah.
You did it.
Yay, Kenny.
And hit enter.
I knew it.
Okay. Yeah. Okay. Now, and I'll show you guys in a sec how to get them to show up. Okay. Now, what we can do to get our second column is actually a whole lot easier. What did we do to get the second column? We took,
Square.
no,
Oh no, you subtracted it.
we subtracted the mean from each score. So, what you can do here is we want to subtract that 60,849 from each of the elements of our list.
So just put down the.
So we hit second list. So we have L1,
Minus.
okay? L1 minus 60,849, okay? When you do an operation with a list and a constant, it will do that operation to every element of the list. So now we hit enter, and it gives us a new list. And just for ease, let's store that. Well, let's store that in L2. Okay, so hit stow, and the list 2 is above the button number 2, and hit enter. Okay? Then what do we want to do with that?
And you square it.
Then we want to square that. So let's just do that squared. Just hit the square key, and it will square every element in the list. Okay? And obviously it's going off the screen. So, let's store that in list 3. Okay? And then, if we go to second list, okay, or wait, not second list.
Can you use second L3 again?
What?
Can you use
3 is above the L3.
Okay.
Or L3 is above the 3. Okay? No, that's not right. Come on. Where is it showing my lists?
Oh, and then you go to math. There it is.
No. Why is it not showing my lists?
L 1.22 to the 21.
Hang on, someone help me out here. How do you get all the table to show all your lists?
Isn't it
second,
fair? Like
second mistake.
Second stat?
you just click 3.
Oh, no, I'm talking about No. Oh, well, you don't have to see it that way. We'll just get back out here. All right, so here's the deal. You've got all your squares, and you can scroll over and see all the numbers if you want, okay? If it won't do it at first, hit enter again, and it'll, and it should. Sometimes the 84s are a little finicky with that, okay? But here's the deal. Now what you want to do is you want to add up all the numbers in that list, okay? So to add up all the numbers in the list, we go to second list, and there is math number 5, okay?
What did you do here? What did you
Okay.
put sum?
Yes, actually you can just type in the word sum and put parentheses.
Can you just use variance?
And hit L3, okay? And there's a really, really big number.
What if you just click the variance one?
Well, the problem with the TI is sometimes they mix sample and population. So
So
we're gonna do it this way.
sum L3.
Alright, so here we have this really big number. Okay? So we found the differences. We squared all those differences to get list 3. Then we added them. Okay? So it was the sum of x sub I minus x bar squared. We've done that part so far. Okay? And when we did this, notice the number we get. We get 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know why they don't give us all the numbers there. Did yours give you the whole number?
Yeah.
Okay, so it's 2, 3, 6, 9, 7, 9, 7, 0, 0,
886.
886. Okay. So what do we need to do with that then, according to our formula?
Divided by an n.
We divide it by an n, okay? And n in this case is how many of these we had. Do you remember how many we had?
No.
We had 25, okay? There's 25, so it's divided by n. So we divide that by n, and you should get,
94791.
okay? So here our variance, or sigma squared, is 94791888035. Okay?
What was that?
Can you remind me
N was 20, oh, and it's right there, 25. Okay? So we divide by 25.
94?
Alright? So how do we find the standard deviation?
Square root.
Square root that number. Okay? So we square root that.
9.
And we get 97,361. I'll put 0.1. Okay? So the standard deviation is 97,361.1. We'll do 1, 2 since we're talking about money. Okay? That means on average, our scores are $97,000 away from the mean. Okay? On average. It doesn't mean all the scores are that far away. okay? But you can see here how, you notice a lot of our data here was pretty close together,
Yeah.
okay? But then you had these couple that were really, really big.
So like they tell you
Okay.
the average salary of a company or something, but it can just have a really big.
Well, in this case, we were told that the average was a certain number, but remember we said that that was misleading because we had these two really big salaries down here. The better piece of data would have been the median, okay? And if you notice here, the standard deviation is dependent on the mean, and notice we have a very large standard deviation, okay? Now, you can have a large standard deviation and have the mean represent the data decently well, but that just means your data is really spread out. And that's what this is telling us here. Our data is really spread out. Okay? So, some of it is kind of clustered in the middle here, but then we've got some really, really low ones, we've got some really, really high ones, and a couple here that are, you know, in the 90s. So we have data that's pretty spread out, and that's what this standard deviation is telling us. Okay? Does that make sense? Okay. All right, now I want to go back for a moment because there is an alternative formula for variance. Okay. Or standard deviation. Okay. They give you the full standard deviation. If you want variance, you just square this. Get rid of the square root. Notice what they do here is rather than subtract the mean from each score, you can just square each score and divide it by n. And then you subtract the mean squared. Okay? So you square each score, divide that total by n, and then subtract the mean squared. Okay, the square root of the mean of the squares minus the square of the mean. Okay? That's one way people help remember it. It's the mean of the squares minus the square of the mean. Alright. Now, one challenge here. Let's go back to this. What's going to be one challenge or thing that you have to remember if you are finding the standard deviation of this data here? Where we're given a data point and a frequency.
Do it because isn't the amount of children and then how many?
So what would we have to do?
You have to list them out, right?
You'd have to list all of them out, okay? The standard deviation here, you couldn't just put in 0, 1, 2, 3, and 4. You'd have to put in 0, 0, 0, 0, 0, 0, 0, 0, and then 1 22 times, okay? So this is where, this is where you're, you have to be careful, make sure you've got them all. But later we can look at some calculator items that do help make this a little bit easier, okay? But just be aware of that. If you're given frequencies, you've got to account for all of the scores, okay? All right, then we have, the standard deviation is used for a few different things, okay? One thing is in different distributions, okay? We're going to look at the normal distribution. We talked about the bell curve quite a while ago. We looked at that a little bit, okay? But in the normal distribution, we use the standard deviation to determine, what percent of our data lies within a certain range. Okay? There's another thing in here, a theorem by Chebyshev. Okay, Chebyshev's theorem says that at least 1 minus 1 over k squared of the numbers in a set must lie within k standard deviations of the mean. Okay?
What if it doesn't?
Well, no, it's a theorem. So, it'll work. So basically, let's look at this. Let's say we wanted a percentage of the numbers to be within, let's say 2 standard deviations. Okay. So let's let k equal 2. All right. So we have 1 minus 1 over 2 squared. Which, what does that equal?
1 over 2, 1
3/4. Okay, 1 minus 1/4 would be 3/4. So 3/4 of the numbers, at least, will lie within 2 standard deviations of the mean. Okay, if we go back to this data here, the mean is 60,000. If I subtract the standard deviation, I'm in the negative, so I know I don't even have to go down any further. But if I go up a standard deviation, that's 150,000, right? Or 157,000 about. If I go up another standard deviation, that's about 254,000. Okay? So look at our data. All but one of our data points lies within that range. So that means, so it works here. It's at least 75%. Okay? So, I have an interesting little theorem there. Chebyshev's theorem. Okay? I listed some problems for you to try. Take the time to do them. Okay? Have a good day.